Example 4 on 8.6. A can of tennis balls usually holds 3 balls. What is the ratio of air in the can to volume of the can? So first, if we draw this out with the canister, should fit 3 tennis balls inside. We know that the distance from the middle and over is a radius. The radius of the can is, we're just coming up with general dimensions as none were given. So I know that if I have a radius from here in this way as well, that's also a radius, 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 radius. We have 2 radius or radii per tennis ball. So one here, one here, one here, one here, one here, one here. R, R, R. So we can say that the height of this canister would be 6R because I know 3 can fit in there top to bottom. And in terms of the radius for volume, volume of a cylinder is pi r squared times the height. So because I know the radius will be r, we needed to have height in terms of r as well. And we don't know any actual dimension, so the height would just be 6 times whatever the radius is. So a way that we can write that, pi r squared times 6r for the height. Simplifying that, 6 pi r times r is r cubed. So volume, this is the can. Let's just leave ourselves a little note. Volume of the air would be 6 pi r cubed, so the volume of the can, minus 4 pi r cubed. Four pi r cubed comes from the volume of a sphere, or one of the tennis balls. Volume of the ball is 4 over 3 pi r cubed, and we said there's going to be 3 of them, so times 3, well, our 3's would really cancel there. Or you can say 12 over 3 pi r cubed, which when you simplify is 4 pi r cubed. So it doesn't matter how you get that, but that is where the 4 pi r cubed would come from. The volume of the can, subtract the volume of 3 tennis balls, will be the volume that the air has. 6 pi r cubed minus 4 pi r cubed is 2 pi r cubed. So now the question says, we have the volume of the can, we have the volume of the air. It says, what is the ratio of air in the can to the volume of the can? So air over can, volume of air over volume of the can. Volume of the air was 2 pi r cubed. Volume of the can was 6 pi r cubed. Any like term would cancel, simplifying 2 over 6 even farther to 1 over 3. So the ratio of volume of air to can is 1 to 3, or 1/3. 1/3 of the can is filled with air. And example 5, if a ball of yarn with a 6 centimeter diameter costs $4 and a ball of yarn with 8 centimeter diameter costs $8, which is the better buy? We can try to draw. Spheres are a little bit harder to draw. And we know that this one would have a radius of 3 or a diameter of 6. And a diameter of 8 would have a radius of 4. Kinda, sorta. Very, very lopsided, but do your best to draw that. So that's just to have a visual of what it would be. So volume of the small sphere. Volume of a sphere, again, is 4 over 3 pi r cubed. Radius in our small sphere is 3. 3 cubed is 27. 27 over 3 is 9, so 4 times 9 is 36 pi. That is the volume of the small sphere. Volume of the large sphere, 4 over 3 pi r cubed when my radius is 4. 4 cubed is 64. Get 85.33 pi for my volume. Now we need to figure out which one's a better buy, so in terms of money. So $4 for a volume of 36 pi or $8 for a volume of 85.33 pi. Again, we want to divide those. So $4 for 36 pi. And we want to divide that by 36 pi so that we have it, our unit rate per one would be 4 cents per 1 centimeter cubed, as our volume is in centimeters cubed. So this is for the small sphere. Now we want to do $8. Yes, $8 over 85.33. Divide those two. I'm just going to erase this to leave some room. And we get 3 cents per 1 centimeter cubed. So the better buy between the two would be $8 ball of yarn would be your better buy. So this one is a better buy. Less money per cubic centimeter. All right, and your assignment, page 508, number 1 to 3, 6, 10, 11, 14. There's a quiz once you're finished all of these sections, and then just your chapter review before your exam. And then you are done, Foundations 20. We have covered all of our content.